Hi, I am Gabby.
Hi, I am James. Together we're preparing for.
ACCAF 5 exam.
Today we're going to talk about.
Linear programming.
Gabby. What is a linear programming?
It is a technique that is used to find the contribution maximizing or cost minimizing solution. When we have one limiting factor, we use ranking. When we have two or more limiting factors, we use linear programming. Let me explain on the basis of an example on the next slide. As you can see, there are several constraints and we are required to find the quantities of A and B that ABC Co must produce in order to maximize contribution. There are two methods to find the solution: graphical method and simultaneous equations method. We'll start with the graphical method. The steps involved are as follows. Step 1. Define the variables. Let X equals number of units of product A produced and sold. Let Y equals number of units of product B produced and sold. Step 2. Establish the constraints. Each unit of product A requires 6 kilograms of materials. So, producing X units will require 6X kilogram. Likewise, producing Y units of product B will require 3Y kilogram. The total amount of materials needed will be. This cannot be greater than 960. So our first inequality is. Similarly, for labor hours, maximum demand constraint, we also need to add non-negativity constraints. Step 3. Formulate the objective function. First, we need to find the contribution of one unit of product A and B. So, the objective function is. To sum up, our model is maximize, subject to the constraints. Step 4. Draw the constraints on a graph and establish the feasible region. First, we turn the each inequality into an equation and draw a line of the each equation. So, we need to draw lines of. You can see the lines on the next slide. Then, we need to establish the feasible region. The feasible region shows all possible combinations of X and Y that comply with all the constraints. When we have less than or equal constraint, the feasible region is either on the equation line or below it. When we have more than or equal constraint, the feasible region is either on the equation line or above it. In our example, the feasible region is shown as the shaded area. Step 5. Find the optimal solution. The best solution will be at a point on the edge of the feasible region. Our objective function is c equals 16x plus 14y. We can choose any value for c, but as a rule of thumb we choose multiples of 16 and 14. We draw that line, which is called an iso-contribution line. Then, We move the iso contribution line away from the origin, keeping the line parallel. The point at which iso contribution line last leaves the feasible region will be a point of maximum contribution. Let's see on the next slide. In our example, iso contribution line last leaves the feasible region at point B. We find the value of x and y at this point by solving simultaneously the equations. And we find that x equals 30. So, our solution is as follows: 30 units of product A and 200 units of product B. Maximum contribution is Another method is simultaneous equations. It might seem that it would be easier to start solving equations without drawing a graph. But in our example, we see that it is pointless to solve equations. That is why it is advisable to draw a graph. Steps 1 to 4 are the same as in the graphical method. Then we find the values of x and y at points of A, B, C and D. After that, we calculate the contribution at each of these points. At this point, x equals 0, y equals 200. Contribution is We have already found values of x and y. X equals 30, y equals 200 and contribution is $3,208. We multiply the equation 1 by 2 and subtract the equation 2 from the equation 3. Then we substitute x equals 120 in the equation 1 and find that y equals 80. Contribution is x equals 160, y equals 0. Total contribution is Finally, we compare contributions at each point and select the point with the maximum contribution. As we know, solution is at point B.
That's end of the lesson.